Hello everyone. This video I'm gonna talk about iterated integral, and sometimes we call this one repeated integral also. If you remember in calculus 1, we had function f of x equal to x squared minus 3x, and when you differentiate that function, your f prime of x was 2x minus 3. Therefore, differentiation move you forward, and which we call this one the derivative, and we can use antiderivative to take you backward. And this one, what you did here, you multiplied the 2 by the coefficient, then you subtract, but you can take that 1 because you differentiate with respect to x. You have to integrate it or find the antiderivative respect to x. But in this case, we have to do the opposite rules. Instead of the negative, we use addition, and instead of multiplication, we use division. Therefore, I take the power of x is 1. I'm going to add 1 to it and divide it by the new power, and I have a 2 here. Here, the power of x is 0. And I put 3x 0 plus 1 over a 1 plus a c. That called the constant of integration in case if the function you started with had any kind of a constant and derivative of a constant was 0. In this case was 0, therefore I can put 0, but what happened if this one was a 2? You have to give me an initial condition to find the function itself. And when simplify this one, that become x squared minus 3x and plus a c, you got that function back. Okay, whenever we went to the multivariables, we had function of x and a y, and we call this one a variable z, which depend on two other variable x and a y. And here, remember, when you take the derivative of a function, we said function, this is a function, the derivative was another function. I can take the derivative of that function, but since this function is depend to two variables, then you cannot take the derivative, you have to take partial derivative. Then partial derivative of z respect to x is 2xy plus 3, and I'm going to put a y here, not x. Then if I want to get that function back, I have to do exactly what I did in calculus 1, take that function 2xy plus 3 and find the antiderivative respect to x. Remember, your y is a constant, therefore that becomes 2x squared over 2y plus 3x plus a c. And that becomes nothing except x2y. And somebody said, what is that c? That c is a constant, but here your constant was a real number, but in here your constant was a y value. Therefore, your constant could become 5y. It could be 5y squared. It could be 0 times y. Therefore, you have to say my function is a function of y. X squared plus y plus 3x plus some constant as a function of y. I get that function back. Then somebody said, what happened if you take the partial derivative of that function, which is right here, respect to y? If I do it respect to y, I get 2x. Then how can I go from here to that function? First, you have to integrate it respect to y, because your x is constant. You pull the whole 2x outside, and that becomes nothing except 2x dy. And what is the derivative of 1 respect to y is 1 the derivative, what function respect to y derivative was 1 is y plus c, your x is a constant. But somebody said, no, I want that function back. Well, you got to take that one and, I'm sorry, take the derivative of 2xy plus c of x and take this one respect to x, because you did it derivative respect to x, you did it derivative respect to y. Then respect to x is 2x squared y, 2x squared over 2y, plus some constant multiples of x. And in here, your y is a constant. Therefore, you have x squared y plus, that's the constant multiples. I'm going to put c1 here and c2 here. c1x plus c2y. Remember what we started with? We started with exactly that function, x squared y plus, in this case, you have to give me initial condition to find that 3. You have to give me initial condition. Therefore, when I find the second partial derivative, first partial with respect to x, then partial with respect to y, I did integration twice. Somebody said, okay, why don't we go right here, and right here, the derivative with respect to y was 2x. Why don't you take this one and integrate it with respect to y instead of doing it twice, and put another integral here and do it with respect to x next. This is called iterated integrals. How do you do that? You have to take the inside integral. Inside integral, the outside is the what? The outside has to be, therefore, all of these has to become function of x. Then you can do it with respect to x. I want to do it with respect to y. Therefore, your 2x is a constant. I pull the 2x out and I put 1 dy dx. I'm going to integrate that one. This is nothing except y plus a c. Do you remember you have a 2x outside? Therefore, right now you have 2xy and plus a c. And that c is a constant, but what did you hold constant? Your x was a constant. Then you're going to do the outside integral with respect to x, and that becomes 2x squared over 2y plus, that's the constant respect to x. I call it c1 respect to x. But when you do it respect to x, you're holding y a constant, and that's become right there. Therefore, instead of doing two integrals, I can do both of them simultaneously. Okay, let's do some examples. See, I have here 3x squared plus 4y squared dy dx. Therefore, I bet you they are asking me, take the integral of this one respect to y first. Whatever your outcome is, do it respect to x. Respect to y, x is constant. Therefore, 3x squared is a constant. And what is the derivative of a constant respect to y? Is a constant times the y. Like if this one was a 3 only, what is the integral of a 3y? Is 3y. And this is 3x squared y because 3x squared was a constant, plus 4y cubed over a 3. But you hold your x constant. But here you integrate it respect to the y. Then you gotta integrate this one respect to x. Respect to x, you're holding the y constant, and you integrate respect to x is 3x cubed over a 3y. Y is a constant. This is a constant. And what is the integral of 2dx? Is 2x. Therefore, this is 4/3 of y cubed x plus, this is a constant. Therefore, this is become C1x. That's C1. I don't know if that's is this 1 or 2 or 3 or 4, but in here you hold the y constant. Somebody said, if I take the derivative of that function respect to x, I should get this. Then take the derivative of that one respect to y, I should get this. Well, give it a try. Respect to x. 3 times 3 is 9. 9 over 3 is 3. You get 3x squared y. Derivative of this one respect to x, it becomes 4/3 of y cubed. Respect to x, like 2x, the derivative is 2. And respect to x, this is a constant, and that becomes a 0. Right now, do it respect to y. Is 3x squared plus 3 times 4 is 12 over 3 is 4y squared, and the derivative of this one is a constant. I get that one back. But someone said, why do I have to know double integral? Why I cannot do two single integrals one at a time? I'm going to show you this is a shortcut to what you did in Calculus 2. In Calculus 2, sometimes you were asked to find the area under the curve between this graph, which is y equal to x squared, and y equal to a square root of x. You said, give me that area. You find the point of intersection. You said x squared is equal to a square root of x. You cube both sides. You square both sides. You bring the x to other side. You factor x. It becomes x cubed minus 1. This is x equal to 0, and x cubed equal to 1, and x equal to 1. Therefore, your point of intersection is 0, 0, 1, and 1. How did you find that area in Calculus 2? You said, I make my x fixed because I divided this one into a rectangle. My y is changing, but every one of these rectangles, the length, the base is delta x. And your x is changes from 0 to 1. And these are your base. But I need the height. The height is the y value. Therefore, this is one y value minus this y value. It gives you that y value. Therefore, the top function minus the bottom function give you between them. Therefore, you said the top function minus the bottom function, and that's how you find the integral. And the integral of the area between two curves. And this one is power of 1/2. It becomes power of 3/2 minus x cubed over 3 from 0 to 1. And that becomes 2/3 minus a 1/3. And that becomes a 1/3. But the student came in and said, why did you fill up the area between those two curves with rectangles which x is fixed but y is changes, and you either use the right corner or the left corner or the midpoint? Why don't I go in this area and divided this one vertically and horizontally, and divided all of these to a rectangle which all of sides are pretty much fixed and is a square shape, and say the area between the million rectangle, I pick one, I call it this one representative, and say the area is a little bit of x and a little bit of y. I said, okay, I agree with you. Instead of this, I do that. Then what do I do with this? Say, take this and sum of this plus this plus this plus, and sum it up. But then I'm going to ask them, this one go right and left, up and down. They said, okay, you can sum it up for throughout the region, the whole region. How? You said the area is dy dx. That's the representative. And what is the region? Region, you can make your x fixed, because it's area. You have to have a fixed number. You have to have a definite integral. Therefore, your x is only go from 0 to 1, but your y is changes. And the y, the bottom function, is x squared, and the top function is the square root of x. I can use double integral instead of that one. Then somebody said, okay, but why did you put dy dx and here you put dx dy? Here is your choice. You can either put dy dx or dx dy. The outside integrals belong to this outside variable. You either make your y fixed and your x changes, because these are your x, see? These are your x value. These are your x value. Your x changes. And when x changes, you write here left and a right. And you write dx dy. But what is your y? Your y was from 0 to 1. But somebody said, what happened if I do dy dx? Dy dx, your y changes, but your x is fixed. Therefore, your y changes right here. You have to put bottom and top. Therefore, it depends which one you get fixed. If you get x fixed, you can go make your y changes and you say top and bottom. But if you get the y fixed, your x changes and it becomes right and the left. Somebody said, okay, give me the answer to that problem. The answer to the problem, what function the derivative is 1 respect to y? Is y from x squared, square root of x, but I gotta take the integral of that one respect to x when I'm finished. And what is this? You have to do the upper, which is square root of x, minus, that's f of b minus f of a, respect to dx, and go from 0 to 1. By doing one of those integral, I get exactly what I did in calculus 1. Therefore, on a double integral, the lower limit and the upper limit, if you graph it, x equal to 0, x equal to 1, y equal to x squared, y equal to a square root of x, these four limits should give you the bounded region. The bounded region. And what is dy dx? Is the square or a rectangle inside that bounded region. You can also do this one too, but somebody said, how do you do this? In here, it has to be a function of y as a left. What is your left? My left is y equal to x squared, but you have to solve it for x because the outside variable is y and everything had to be changed to a y. Therefore, you have to say x equal to a square root of y. Your left is a square root of y. But the right, which is this, is y equal to a square root of x. Your x is y squared. Therefore, instead of a right, you put y squared. And you get the same answer as this one. And somebody said, okay, I agree with you. But tell me, I have 0 to 3, and I have 0 to 1, and I have 3x squared plus 4y cubed dy dx. And they're going to ask you, can you interpret this one for me? I said, yes, this is your region. What is your region? Because the outside is dx, this belongs to x. The inside is y, this belongs to y. X equal to 0, that's x equal to 0. X equal to 3, that's x equal to 3. Y equal to 0 is right here. Y equal to 1 is right here. That's my region. That region, unlike the previous region was a crooked region, is an irregular shape. But that's the regular shape because x is a straight line, y is a straight line. There is no curve in here, means your dx and dy both are fixed. Therefore, if you do have a region and the region is again is like a regular shape and all sides are straight line, you don't need a variable. All are fixed. But I'm going to say this area represented a lifespan of somebody. And this function represented how much money they save at any given time. Or somebody said, this is nothing except, and somebody tell me what is the mass. Mass is density times area. Well, that's the area. And here is a multivariable. I bet you your density is a function of x and a y. Therefore, that's 3x squared plus 4y cubed. That also another example. I can say I'm trying to find the mass of that area, which the density is varies. This rectangle was not made of a uniform density. One piece is one material, this piece is another material, this piece another material. They have a different density. Therefore, I want to know what is the mass. Mass is density rho times the area. Then, how do you find the mass? You have to do this one respect to y first. Respect to y, only you integrate the y. Everything else is fixed. Therefore, 3x squared is a constant, dy. What function is derivative is 1 respect to y? 1. Then the first one is 3x squared y. This one is 4y cubed. You doing it respect to y is 4y to the power of 4 over 4. Therefore, plus 4y to the power of over 4. From where to where? From 0 to 1. And remember, that 0 to 1 is only belong to the y. And that becomes 3x squared. And this one is 1. 1 to the power of is 4 is plus 1. When I put 0 for y, that's make it 0, 0. Then see, everything came in terms of x. That function have to be integrated from 3x squared plus 1 respect to x. From where to where? 0 to 3. 0 to 3. And that becomes 3x cubed over 3 plus x from 0 to 3. That's 27 over 3 is 9. 9 times 3 is 27 plus a 3. Therefore, the mass of that plate is 30 pound with a different density. Therefore, these are examples and these are double integrals. But somebody else is going to say, you know what? I have this region in my backyard. And in this backyard, I have an umbrella on top of it. And they said, what is the height of the umbrella right here? Is 0. Because when I put 0 for here, you get 0. Here, your x is 1, your y is 0. Therefore, the height of umbrella is 3. In here, the height of umbrella is 4. In here, if it's 1 and 1, the height of umbrella is 7. Therefore, here, that z represents the height. Then what is the volume of that solid? The volume is base area times height. The base area is divided into infinitely many square, and that's right here. That's your area. And what is area times the height? Volume. That's another example. It could be a volume too. It could be a math too. It could be the saving of somebody who lived his life in this area and he was saving money at that rate. That's the cumulative sum. Therefore, you can use double integral to many different applications. This is the starting video to give you at least some ideas, and I'm going to put more video up. Hopefully, we learn more about double integrals or iterated integrals And then we're going to go on to triple. Triple, you take dy dx dz. On a dy dx, you can either write it dy dx, this is called Fubini, or dx dy, because this is 2 factorial. But if it's dy dx and dz, you can write this one as a 3 factorial, and you can have 6 different combinations for that. Therefore, for dy dx, you have only 2 different combinations, but if it's a 3, you have 6 different combinations. Thank you.